All right, let's get right into it. There's this brand new, kind of revolutionary school that just opened up in Beijing. But here's the thing. The students, they're not human. Yeah, you heard that right. It's a school where robots go to learn.
So just think about that for a second. What if a robot could actually learn to do things around the house? Cook a meal, sort your laundry, maybe even care for someone, in the same way a little kid figures out how to walk. That's the huge question at the heart of this whole thing. We're not just talking about AI as code on a computer anymore. This is about physical intelligence, learning by doing.
Okay, so to really get how this all works, we've got to meet the star student, the one at the very center of this whole revolution. And here he is. This is Kuafu. He stands about 1.66 meters tall, and get this, he's named after a giant from Chinese mythology who literally chased the sun. How cool is that? And Kuafu's already kind of a big deal. He was the world's first humanoid robot to be a torchbearer for China's national games. I mean, wow. So now he's taking on his next big challenge, becoming the very first student at this one-of-a-kind school. So what exactly is this robot school? Well, think of it as a huge, specialized training center. Its whole reason for being is to pull robots like Kufu out of the clean, predictable lab and throw them into the real world. To teach them all the messy, complicated skills they need to actually function out here with us, turning them from a cool prototype into a genuinely helpful assistant. But the really fascinating part is what goes on inside. So let's pull back the curtain and take a peek inside this incredible facility. It's basically a robot boot camp. First off, this place is massive. We're talking over 10,000 square meters. And no, it's not just some big, empty warehouse. It's filled with these perfect, full-scale replicas of real-world places. Think factory floors, entire home kitchens, even bedrooms. The idea is to have the robots train in the exact same kind of space they'll eventually be working in. And the way they learn, it's actually brilliantly simple. So step one, a human trainer, sometimes decked out in a motion capture suit, just shows the robot what to do. Step two, the robot tries to copy it over and over and over again. And here's the most important part. With every single try, it's generating this fire hose of super high-quality data that gets fed right back into the AI. So the whole system gets a little bit smarter with every single repetition. The head of the center, a guy named Zhu Kai, has the perfect analogy for this. He says, just as children require repeated practice to walk, robots must train extensively across diverse scenarios to build functional intelligence. I mean, it makes so much sense, right? A toddler falls down 100 times before they can walk. These robots need that same kind of massive practice to build what he calls functional intelligence. And when we say massive practice, we are not kidding around. We're not talking about trying something, 10 or 20 times. To master one single precise movement, something as simple to us as just placing a pan on a stove, can take up to 1,250 repetitions, 1,250 times. That just shows you how dedicated they are to getting this perfect, usable data. Okay, so this school is obviously super impressive, but how does it fit into the bigger picture? Well, it's really important to understand that this is not just some cool one-off science project. It's a critical piece of a much, much larger national strategy for China. And I mean, the government has laid out a crystal clear roadmap. The goal for 2025, have a whole innovation system up and running for humanoid robots. And for 2027, build a secure, reliable supply chain right there at home. This isn't just a whim. It's a very deliberate, long-term strategic play. And of course, they are backing this up with some serious cash. In just the first 9 months of 2025, more than 50 billion yuan was poured into China's robotics industry. That is just a staggering amount of investment. And this brings us to a really crucial point. This school in Beijing, it's not working alone. It's actually the main hub in a whole national network of these data centers. They're all working together, all feeding into the same system to create this one gigantic, standardized data set. The goal is to speed up the creation of general-purpose robots that can work pretty much anywhere.
So with this huge national push, you have to look at the global stage, right? Because none of this is happening in a vacuum. It's all part of this incredibly intense global race for who's going to lead the world in what we call embodied AI. And when you look at the two biggest players in this race, China and the US, you can see they have totally different game plans. The US, well, it's got a big lead in that foundational deep dive AI research. And of course, it has all the big tech giants. But China's playing a different game.
Their strengths are their massive manufacturing muscle, that powerful government support we just talked about, and a laser-like focus on one thing: getting these robots out of the lab and into the real world, making money as fast as possible.
And you can really see the momentum building. Just look at the patent filings for humanoid robots over the last 5 years. The trend is, well, it's pretty shocking. China is filing patents at a rate of nearly 4 to 1 compared to the US. That tells you everything you need to know about where their strategic focus is.
And these robots, they're already graduating and getting jobs. This isn't just theory anymore. They're out there in the real world right now. They're handling materials in auto factories, delivering packages for big investment firms, and even doing inspections on the power grid. It's happening.
So, okay, things are moving incredibly fast, which leads to the big question. What does all this actually mean for us, for our future? And that brings us to the final and, maybe the most important part of this whole story. The big questions we really need to start asking ourselves.
Because, look, this kind of progress doesn't come without some huge challenges. I mean, there's the obvious stuff, like what happens to jobs. But there are also these massive practical problems to solve. How do you make absolutely sure these things are safe when they're working right next to people in chaotic, unpredictable places? And maybe the biggest hurdle of all, how do we, as a society, learn to actually trust them enough to let them into our lives? And that really brings us to the final thought here. This isn't some far-off sci-fi movie anymore. This robot school is being built to train and graduate millions of these robots. And as they start walking into our factories, our offices, maybe even our homes, the question isn't really if this is going to happen. It's happening. The real question we have to ask ourselves is, are we ready?